Let's take a look at this problem involving inverse functions. So we're given that f of 1 is equal to 4, f prime of 1 is equal to 2, f of 4 is equal to 10, f prime of 4 is equal to 3. The question is find f inverse of 4 and f inverse prime at 4. All right, before solving this problem, I want to point out something that'll become clear as we solve it. This piece of information and this piece of information are useless. We do not need that information to be able to solve this problem. What's only needed are the two items that I did not cross out. All right, so f of 1 is equal to 4. That's given. And so by definition, that means that f inverse of 4 is equal to 1. Okay, so that's the first part. So f of 1 is equal to 4. Reversing the roles, f inverse of 4 is equal to 1. Okay, now to find this, f inverse prime at 4. So we have a formula for that. F inverse prime at 4, that's equal to 1 over f prime at f inverse of 4. Okay, f inverse of 4, we just found out, is equal to 1. So that's 1 over f prime at 1. And f prime at 1 is given to be equal to 2. So the answer is 1/2. Okay, so short story, there are the two answers. F inverse of 4 is equal to 1. F inverse prime at 4 is equal to 1/2. So you can stop the video here if you got that. Those are the right answers. With the rest of this video, I just want to take a moment to remind ourselves as to why this works in the first place, why this formula is correct, or at least to try to give an intuitive explanation as to why it works. All right, so let me draw the graph down here of something that satisfies this. So f of 1 is equal to 4, so here's the point 1, 4. And the slope of the tangent line is supposed to be 2. So we have a slope of a tangent line, looks like it's about 2 or so. And so the graph of the function could look something like this, just to eyeball something that might work. So in orange, this could be the graph of the function f. Okay, now if that's the graph of the function f, how do we graph the f inverse? To draw f inverse, we would then reflect through the line y equals x. So here is the diagonal line y equals x. And then I would take the graph in orange and flip it down, or sorry, reflect it through the line y equals x. In this case, that'd be flipping through the line here. So the point 1, 4 would then flip over to 4, 1. And this graph in orange is probably going to go something like this. Again, I don't want this doesn't have to be perfect. I'm just trying to sketch the idea of what happens. Okay, now what happens to the tangent line? The tangent line will go like this now. And what happens to the slope of the tangent line? Over here, this rise over run is equal to 2 over 1. That the slope of the tangent line is 2. When I reflect over, the 1 becomes over here and the 2 goes over here. So the rise is now 1, but the run is equal to 2. And so the role of rise and run flips. And so it makes sense that the derivative of the inverse is equal to the reciprocal of the derivative of the original point. But I don't plug in 4 here. I plug in 1, f inverse of 4, when figuring out the reciprocal. So that's just a brief recollection as to why this formula works in the first place.